So today I would like to try to go over error handling, like how to be able to create your own errors for your packets, things like that. That type of error handling, which I guess boils down to how to convert somebody else's third-party error into your own error, and that you could consistently use your own branding of error. Let's get it. All right. So like I was saying, how to convert somebody else's error, third-party error, into your own. Deals with conversion, and luckily the standard library tells us exactly how to do that. We have a standard convert from. Oh, and I'll put links to all of this stuff in the description, so no worries. But more or less, there is a trait from that allows you to convert from something to make something else. There's also the reverse direction. So let's say if you want to take something and make it into something else, that would be the reverse. Like you can go from A, make B, or you can take B and make A. So there's two sides to that direction, right? But it does state that you should always prefer the from scenario because the implementation for into will be automatically provided for you via the compiler or something along those lines. But what does this have to do with error handling? And they kind of just tell you right here. The from is also very useful when performing error handling. When constructing a function that is capable of failing, the return type will generally be of the form result type error. The from trait simplifies error handling by allowing a function to return a single error type that encapsulates multiple error types. And then they have the C example. Right? So let's go to their example real quick so you can see what they're talking about. So they have some imports, file system, IO, number, but I think this is what they mean. Right here, they have an enum called client error, and in it they have one brand of error which is called IO error, which takes an IO error, and another brand of error called parse error, which takes a number parse error. Okay, and then you can see the froms being implemented, right? From IO error, which is right here, we want to create a client error IO error, and we just pass in the error right there. And we do the same thing for the number parse int error. Take the error and just pass it into our brand of error. So then we come down here and we see a function that they have here, open and parse file. Which, okay, we have the file system, read to string, and then we have a file name, which could fail because the file could not exist. And then we have this question mark. Down here we have a number, we're converting it to I32, and we have contents, trim, and parse. And we're trying to parse it into an integer, which could fail because the contents of the file could be a string. But hold on for that thought real quick. One thing I really want to go over is this question mark. So this question mark seems to be a shortcut of some sort, but what exactly? And when I was doing some research, I found this. So in the addition guide, which covers, I guess, maybe the specification changes in Rust over time, the 2018 edition has a section called the question mark operator for easier error handling. So in this, while going through this, and I'm not going to go through it all in detail right now, we see that the question mark, in terms of the reason why it was created or added to the language, is simply to reduce boilerplate in error handling. So here we have an example, right? We have read username from file, and there's a result type like they just described. This is the common thing that we see: a result, a type, and an error. But in here we have something that can fail. We open a file, and then we check to see if it's okay or if it's an error. And this is our error handling. We do something with a string, create a new string, and then we try to read contents to a string. And then again, we have the same type of error handling. And this, they could have done this in one function convenience call, which they note here, but they did it in two separate ones because they want to emphasize that this stuff, this max expression, is just boilerplate. So we see going down here that they replaced the boilerplate, the match expressions, with the question marks, which gives us the implication that the question mark is more or less writing these match expressions for us. The check to see if it's okay. If it's not, throw up an error. Okay, that makes sense. We come back to here, we see we have the question mark, and we can internalize that this question mark is more or less just a match condition on the okay and error. But going back to the boilerplate for a second, looking directly at it, we see no association with a conversion. So why, that begs the question, why is this in the standard convert from section of the standard library? Like this example at all, this question mark, why does this work? But that's explained here. So in this paragraph, they say, while performing error handling, it is often useful to implement from for your own error type. By converting underlying error types to our own custom error type that encapsulates the underlying error type, we can return a single error type without losing information on the underlying cause. So this is explaining the reason why you want to do this, which is encapsulating the original error type within your own. But it's the next section that's the juicy part. The question mark operator automatically converts the underlying error type to our custom error type by calling into, and they have the type of error that's in the example, client error, into, which is automatically provided by implementing from. The compiler then infers which implementation of into should be used. So from here, we know that this question mark not only does a match and then tries to return an error in the case of error, but whatever error it returns, they're going to try to do a conversion to the error type that's specified here in the result. And they know how to do that, one, because they can imply it, which, I mean, if you have the result, you know what error types should be returned back. But they can also check for into implementation and try to convert that error into the generic type that you already implemented with your enums in your section, in your error variations. And the reason why you have into is because if you implement from, you get into automatically. So let's see this in practice. And I'll open my terminal real quick. Well, not my terminal, my editor. We can just copy and paste this though real quick. So copy all of this. Copy. And I have just a new project here. It's empty. Oh, I think this may be a little bit too big. All right, so I have my editor open. And let's copy and paste this to make sure it compiles, because if it doesn't compile, then we have issues. Terminal, cargo run. And we see the hello world, because the hello world is here. Everything compiled. All right, nice. So there's going to be an error. Let's try to visualize those errors. All right, so based on everything we know, we should be able to open and parse a file. We can pass in a file that doesn't exist, and we should get an error back, more or less. And in terms of error handling for a main, we have to be able to pass back a result. At least it's the way I've seen it done. We can do a random empty unit okay, and then for the error, we know the error is going to be a client error. And then at the end of this, we can just give an okay. Cool. And then when we run this, we get an error. Note that this error states that the trait debug is not implemented for client error. So why does that even matter for this? And it states here that it's required because of the implementation of standard process termination for the result. So more or less, at least the way I internalize this is that when main returns an error, that error is going to be printed somewhere. In order for that error to be printed, we need at least an implementation of debug. Okay, so we can just derive that. That's what they suggest here. And derive should work because, hold on, let me just write it real quick. So when we derive things typically, right? Derive is going to go through all of the fields of, I guess, the variants and check to see if they implement debug themselves. And as long as they implement debug themselves, then we should be fine. At least that's my assumption of how this works, based on the other things I've seen with derive. IO error probably already implements this. Number parse int error probably already implements this, so using derive seems fine. And plus, we just want to propagate the error, like wrap it and propagate it. So changing things doesn't really seem appropriate. Cool, so now we get an error message. Note that it is an error. Note that it is an IO error, which, if you come back to our implementation, is the exact error that we want because that is a variant of CLI error. And then we have the wrapped error of the IO error, which says OS code 2, no such file or directory. That makes sense. So in order to fix something like that, we need to create a file or directory. And then let's just create one right here. Touch, call it testing, nano, testing. That's sort of weird to have nano in my editor, but okay. Call it testing stuff. And ls, we see that testing is now here as a file. So given that testing now exists, let's see what happens. Cargo run. We get a new error. We see error, we see that it's a parse error, which coming back to our errors, parse error. It is something that we define, this is something we want, and we're wrapping the parse int error. And we see that right here. Here is the parse int error. And it states that it's an invalid digit, which makes sense. So coming back to the open and parse file, right? We have now been able to find the file and read it. Then we try to trim the seemingly white space and then parse it into an integer. But the content of the file is a word, a string, testing. That doesn't parse into an I32. And thus we get the error here. But this brings back to the first point, which is we were able to create our own style of error for our, this is in theory could be a package. And then we were able to return or use the error type of our error and then have this automatically do the match statement and the conversion from whatever the original error was into our error, which is the CLI error. So that's pretty much what I want to go over today, just because I really care about errors and how they're handled, and I wanted to understand how this was done in Rust. But there are some cool things. I did discover that there is a crate dedicated to doing error handling and make it easier, as in taking away some of the, or almost all of the boilerplate for you, called error chain. I haven't really looked into it myself, but I do know that it exists, and if you don't want to write your own from implementations for everything, little thing, like every type of error that you can do the conversions for, then error chain is probably what you want to look into. And just in terms of from and into, another thing I noticed was that the Rust by Example book has examples on both from and into, and the examples do not deal with error handling. So if you want to understand how to use from in the case of converting from a type like a, I don't know, a I32 to your own type of number, then that is here as well. And they go over into in a similar fashion. Yeah, so with that, I think we have reached the end of this video. I hope it was insightful for how to create your own errors and convert them, and how the question mark operator works underneath the hood. If you like the video, hit like, subscribe. Outside of that, peace.